Hi guys, I'm so sorry that I'm not able to be there again today. I'm really not feeling well. I'm going to be headed to the doctor's today, so hopefully she'll be able to fix me up and get me back to you really quickly. Um, as promised, I wanted to be able to share a video with you for this unit, especially. This can be pretty tricky, so I'm glad that there's going to be a video of it so that you guys can listen to it a couple of times and refresh everything. So you're going to be turning to Module 14.1 in just a little bit, and it's on page 437. Don't do it just now. I want to explain some things to you without you seeing the page because that can be a little bit confusing sometimes. Before we begin, let's talk about the word rational and irrational again. Remember that word rational had the word ratio in it, and it was any number that could be written as a ratio of one number to another number, like as in a fraction. It can also be written as an actual ratio. Remember, they included all positive and negative integers. Remember that? So that was whole numbers and their opposites. And so positive 3 and negative 3 are all rational numbers. Remember, it included decimal numbers because fractions can be turned into decimals. So 2.5 or 2 and 5/10 is a rational number. And it also included numbers that are decimals that are repeated. So if I have 1 and 0.3 that's repeated, that's considered a rational number, and we're going to talk more about that today of why it is considered a rational number. And also numbers that were terminating, like 2.5, or it could also be a number that repeats over and over again, like if it was 1.53 535353 continuously. If a number repeats itself or if it terminates, then it's considered a rational number. Okay, so rational number includes the word ratio in it. And we're also going to be talking about irrational numbers later in there, and we were talking about irrational numbers include numbers that are decimals that don't repeat, but they go on forever. So infinite decimal places that never repeat, such as pi. Okay? And so there's your recap right there. Let me go ahead and clear this page for us and take any notes that you need to, rewind and re-listen to it again if you need to. But we're going to start off with a little bit of a review. Let's go ahead and say we have a fraction, which is a rational number, and we want to turn it into a decimal. You just took a test on this. I'm glad that we're starting off rather slowly. What are the steps that I would need in order to convert this into a decimal number or a rational number? Rational number as a decimal, right? Yeah, you're right. I would take the 1/4 and I would divide it, drop the 1 into our dividend, and then I would continue that problem, right? So it would be 4 into 1, or 1 divided by 4, and I can't go in at all, so I add that decimal place, add my 0. Here's where we talked about before that it's really important that you do not lose your place value right here. I bring it straight up since there's no decimal place in the divisor. Out here with the 4, there's no decimal places, so I just move the party right to the top. And then I say, how many times can 4 go into 1? Well, it can't, so I hold that place right there. That's going to be really important, especially when you're dealing with decimal numbers. And then I can ask myself, does 4 go into 10 then? And then, yes, it does. It goes in twice. I multiply 8. I have 2 left over. I can add that 0 and bring it straight down. And so now the 4 into 20 can go 5 times. And it's 25 hundredths is my final answer. And so this is a terminating decimal, right? No big deal there. It is a rational number. Feel good about that one? Yeah, no problem, right? And you can do the same thing if it was a whole number that you had a mixed number or something like that. You could do the same process. You can, if it was 3 and 1/4, well, then you know that this whole number in here would be a 3 as well, right? There you go. So let me clear this ink again. And let's go on to something a little bit more complex. And let's say that you have a number that's 1/3, and you want to change that into a decimal number. And of course, we know it's going to be a ratio, correct? And so go through the same process. The 1 becomes my dividend, my 3 becomes the divisor. And so I like to write it clean over on the side here. And so 3 can't go into 1, so I add that decimal place and bring it straight up. Keep everything lined up. And I know it goes in 0 times into 1, but it can go into 10 3 times. And I know that my answer is 9 after I multiply them. I subtract, I end up with a 1, and we already know the pattern that's going to happen. I'm going to be repeating 3's over and over and over again, right? As you see, the pattern's going to keep on going. And so my answer to this problem, 1/3 equals 3/10 as a repeated fraction. And so it will go on and on and on. This is still a rational number. Okay? So whenever you're doing the division of these problems, please make sure that you go maybe to the thousandths place to make sure that they repeat each other, or that it is a terminating decimal or a repeating decimal. You should be able to find out by the thousandths place or the 10,000ths place, and then you should be able to see it at least in the problems that we're going to be doing. Now, that you will be able to see all these problems on this page in your book right now. I just took you the easy way through it, but you have the definition of the rational number up here again, the terminating decimal, the one that ends, and the repeating decimal, the one like the 0.03 repeated is a repeating decimal. And you don't want to do it like this. Here's how you correctly write it. You do not want to do this. That's incorrect. This is the correct way to notate it, okay? You just want to do the numbers that are repeated, like if it's a 54 that's repeated, you don't write 5454 repeated. That's wrong. You just put that bar above the numbers that are repeated the first time you write them. Does that sound good? Okay. So now we're going to review what you did when you turned a decimal into a fraction. And again, you just had this on your test. So it should not be much of a stretch for us right now, especially this first problem. Remember, whenever we're turning a decimal into a fraction, they're both rational numbers. And so we want to write it like you say it, right? Write it like you say it. And then write it like you say it. But then we simplify afterwards. Those are our steps. I'm writing with my fingers since I don't have my stylus at home. Sorry about that. Simplify. Okay? And so let's say we have the number 825 thousandths, and I want to write that as a fraction. So again, I write it like I say it. So 825 thousandths. That's how I write it as a fraction. However, I know that I can simplify it. I know that it can be divided by 25 because I know anything that ends in 25 can be divided by 25, and anything that ends like it's a multiple of 100 can also be divided by 25. But if you didn't know, you could take it by 5s if you wanted to, or see if there's anything else that's divisible into both of those. And if I divide by 25, I simplify it into, let's see, 33/40ths. And that's it. That's how you change a decimal into a fraction. So that part is something that should not be confusing to you at all. If it's a terminating decimal, then it's very simple to change a terminating decimal into a fraction by simply writing like you say it. Now, here's where I really want you to pay attention. You might have to watch this a couple times, but what gets tricky is we said that a repeating decimal is also a rational number. So let's say that I have the number 37 hundredths that's repeating. So 37 hundredths, it's a repeating number, and I want to change that into a fraction. Now, I want you to just watch for a second and just pay very close attention to everything that I'm doing. And you might need to watch it a couple of times. But don't get yourself overwhelmed by it. You're going to kind of shake your head a little bit and be like, what just happened? Don't worry about all of that. I want to show you how it can be written as a fraction. I'm going to tell you right now that the answer is going to be 37 over 99 though, okay? I'm going to give you a little clue. Any repeated decimal is going to be the number that's being repeated over the number 999, 999, depending on how many digits it is. So let's talk about that for a second. So I'm going to give you a couple answers. So if I have the number 512 thousandths, then it's going to be 512 over 999. Okay? If I have the number that's if it's repeated. I'm sorry, that's if it's repeated. If I have the number 7/10 repeated, then it's going to be 7 over 9. Now, that's the answer. Let's talk about how I come up with it, and let's work backwards. I'm going to stick with this number 37 hundredths repeated to begin with. Okay? Here's how it works. You have to set up a problem that says x equals 37 hundredths repeated. That means it goes on and on and on and on and on. And so we give this unknown value x, and we're going to say that it equals 37 with it repeated because there's no way that we can actually write that number. You agree? We can't write that number out, so we're just going to give it a value of x right now, okay? So hang with me, and you must put this down as x actually equals it because we cannot write the number 0.37 repeated. We can't actually write it, okay? So what I'm going to do is I'm going to take, you remember how we can do both sides of the equation? Whatever we do to one side, we do to the other, and they remain equal. So I'm going to take this number and I'm going to multiply both sides by 100. I chose the number 100 because I'm in the hundredths place. So if I multiply this times 100 and multiply this times 100, so 100 times x equals 100 times 0.37 repeated. Do you agree? They would be equal to each other because right now this x equals 0.037. So it's essentially saying 100 times 0.37 equals 100 times 0.037. Do you agree with that? Okay. So let me erase all these little marks here. And these two sides are equivalent to each other. So if I continue with this problem, I simplify it and it becomes 100x equals 37.37 repeated, right? Because there's just more 3 7s behind it. And since x equals 0.037, I can now subtract an x. Essentially, I'm subtracting one x from both sides. So I'm going to subtract an x from here, and I'm going to subtract x from here, but remember that the x is that 0.037 repeated. So if I subtract x from here, I'm left with 99 x's left. Does that make sense? Because this is essentially 1x. Does that make sense? Okay, so you have 100 x's, you take away 1 x, you're left with 99 x's. And on this side, if I take away that x, I'm taking away that 37 repeated because x equals the 0.37 repeated. So I'm left with 37. Kind of racks your brain a little bit, doesn't it? So if I want to find out what x equals, what do? I get it by itself. So I divide both sides by 99, and I'm left with x equals 37 over 99. That will work for every single problem that is a repeated decimal. I'm going to do that one more time for you, and I'm going to try to find different words for it. Now let's say I have the number 826 thousandths repeated. I know that this is a rational number because everything that has a terminating decimal or a repeating decimal is a rational number. That means I need to be able to write it as a fraction. There definitely is a way to write it as a fraction even though it's repeating because it's considered this rational number. Now, based on the shortcut that I told you before, I already am going to know the answer to this problem. It's going to be 826 over 999. And the reason why is because there's 3 decimal places that are repeated. So that means that there's going to be 3 9s in my answer. So I know that this is going to be my final answer. Sometimes you can work backwards, but you do need to know this process for the test. So you might have to watch this a couple of times. So the first thing I'm going to do to prove that this is my answer is I'm going to set up x equals 0.826 repeated. And because I now want to work on this problem, I'm now going to multiply each side of it. Remember, if I multiply both sides by the same number, they stay balanced, right? I'm going to multiply each side by 1,000 this time. Last time I did it by 100. This time I'm going to do it by 1,000 because I want to turn these 3 digits into a whole number. So in order to do that, I've got to move the decimal place 3 times, which means I'm going to multiply by 1,000. So I end up doing 1,000 times x equals 1,000 times 0.826. 826. Let me turn this into an asterisk so it's not confusing. Man, I'm using x's and I'm using dots. It's really confusing, but this is multiplication. I should have used some parentheses. Maybe that would have been a little less confusing. Sorry, guys. So if I do this problem and I simplify it, do you realize that both of these sides are balanced right now because my x equals this, right? So these sides are both balanced. Here I go. I end up with 1,000x over here equals 826, because I'm going to move that decimal point over 3 times, 0.826 repeated, because this does not ever end. It's 826, 826, 826, 826, and it goes on and on and on. So essentially what I did is I moved this decimal point over 3 spaces. I ended up with that whole number, and then these guys repeated each other over and over again. Does that make sense? So now what I'm going to do is I'm going to subtract out x. The reason why I'm subtracting out the x is because I want to get rid of this guy. I have to get rid of this. I have to get rid of that repeated number over and over and over again. And if I take an x if I take x over here, x equals this, so my sides of my equation are still balanced with each other. So if I take away one x over here, and if I subtract x over here, they're still going to be equal to each other. But if I have 1,000 x's and I take away one x, I'm left with 999 x's. And over here, I get rid of these repeated decimals, and I'm just left with 826. Does that make sense? So I'm left with x over here. I could have put this as actually, let me instead of saying minus x over here, let me just say minus 0.826 repeated. How about that for you? Does that make sense? Because I subtracted x from one side and the 8.26 on the other side. Now, if I want to get the x by itself, which I want to find the value of x, I simply divide by 999 from both sides. That means that I'm left with x equals 826 over 999. My final answer. For the rest of the class period, you can watch the video again, meet with a teacher. But definitely make sure for classwork or homework you attend to the following: page 442, numbers 1 through 12, and page 443, numbers 20 through 27. Make sure that you do understand the steps for converting a repeating decimal into a fraction. You will need to do that for the test, and you will be required to show all of the steps for that. So if you have to watch the video a couple of times, or talk to Miss Renee or the substitute or a classmate or me when I get back, make sure that it's something that you do address and make sure that you fully understand. I hope you have a great day. I miss you guys, and I'll see you soon. Bye-bye.